Good evening, everyone. Uh, my name is Rajat Bani. I am from IITISM Dharma and one of the PhD research scholar at IITISM Dharma and also a PMRF candidate. I am taking this ground improvement live session uh, and which is one of the discussion session regarding the week lecture, which is taught by the Professor Dilip Kumar Baidu sir at his Nptel account, and I am one of his TA through the for this course, and I am discussing. This session is about 2 hours. I am discussing this all the week classes one by one through the PPT, which is already given and at or already available at NPTEL site, and also I uh, 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 also, I tell you that this session is will recorded and also provided you through NPTEL in my YouTube channel, and also whatever I am discussing in this session, uh, uh, all the materials will be shared to you through Google Drive by NPTEL team. Don't worry for that. And if any technical issue is arise and I am getting disconnected, please don't worry. Be in the line. I will join in few minutes. Don't worry uh, about that. And now I start today's ground improvement session. It will first we I discuss about the week's lectures one by one through PPT. Then I discuss about one problem of this week and also try to solve previous year assignment problem in this session. And if time permits, I will also discuss about your doubts regarding this class. Okay, don't worry there. And also, I also like uh, uh, to wish you that it is in 15th September. It is Engineers Day, and I wish everyone a very happy Engineers Day. And this day is celebrated for on the birthday of first engineer Sudham Vishesharya, and he is a well-known person in his field. He is also a civil engineer, and we proud for him. We proud to be an engineer. So wish you for happy Engineers Day, everyone. Now I am starting my today's session. I'm sharing my PPT. Please stay on the line. Uh, I think my slide is visible to everyone. Sorry for that. Uh, I think my slide is visible and also my voice is clear. So now we start our today's discussion. Today we discuss about another ground improvement technique which is called grouting method, and it is which mostly used for repairing purpose of existing structure, also used for control the water uh, seepage into the foundation. and like also sometimes used to improve the ground bearing capacity. This method is mostly costlier sometimes and give sufficient result uh, for sufficient result for our targeted value. And this method, this grouting method, mostly used when the other methods of grouting is not applicable to the site, and also this method is used when we improve the existing structure, or we repair the existing structure. Then only we use this type of this routing method. So I mean, in the next, now we discuss one by one every slide. So first, the introduction of the grouting. It is said that we injection of the slurry or a liquid solution into the soil or rock formation. The grouting is mainly the injection of a slurry or liquid solution into the soil or rock. This liquid solution may be soil, cement paste or cement water, or sometimes clay paste or clay water, clay cement water like that, or sometimes maybe some chemical solution. Okay. Then the grout subsequently harden, increase the strength, decrease the compressibility and permeability. These are its application where we apply. When we apply this grouting, it increase the strength, decrease the compressibility of the soil, and also reduce the permeability of the soil. For this purpose, we mainly use the grouting. The next slide, it is discussed about the mode of different modes of grouting. In how many ways we apply the grouting in the in our soil or in our substructure like that. The first one is the permeation or penetration grouting. In this, the grouts flow into soil voids freely with minimal effect. That means we just apply the grout into the soil without any pressure. By only the gravity, this grout is penetrated into the soil and then harden and increase the strength and reduce the permeability and compressibility of the soil. The next one is compaction and or control displacement grouting. Here, we actually compact through grouting. We compact our surrounding soil, and by this compaction, we improve our grouting. So it is said that this grout remains more or less intact as a mass or and exert pressure on the soil. The next one is hydraulic fracturing or uncontrolled displacement grouting. So it is said that the grout rapidly penetrates into a fractured zone created when the grout pressure is greater than the stainless strength of the soil or rock. That means when we apply the grouting by some pressure which is greater than the stainless strength of the soil, and due to this pressure the crack develop, and through this crack grout materials enter and improve the surrounding soil or rock for our construction purpose. So the fourth one is compensation grouting. It is said that it is used to compensate the ground loss due to the construction activity such as excavation or tunneling. That means this compensated grouting mostly used for the tunneling purpose. If when we excavate, some soil material may collapse. To fill this soil material or voids or cavity, we use that type of compensation grouting. The last one is jet grouting. It is said that it utilizes grout to erode the soil at a depth and then mix the eroded soil with the grout to form hardened columns and walls. That means when we apply this jet grouting into the soil, the jet grouting mix with the surrounding soil and create some cement paste or some paste like structure, and after some period of time this paste is hardened and uh, uh, and improve our soil. Like that way, a different way we improve the soil through grouting. Uh, the next slide, it is show that different grouting techniques, schematic diagram of the different grouting technique. The first one is show here is also about the permeation grouting. Just only we apply the grout through the pipe, and nothing we apply, not any pressure is applied on that. Through gravity only, the surrounding soil is grout material enter or penetrate to the surrounding soil, and then the soil is improved. The next one is compaction grouting, and we apply some grouting through by pressure, and due to this pressure, surrounding soil may compact it. By this way, we improve the grout. Third one is hydrofracture grouting. Due to the high pressure, the surrounding soil may crack or the rock may crack. After that, the grouting material enters into the surrounding soil and improve our soil, our rock. The fourth one is the compensation grouting. So in compensation grouting, the structure, we actually apply the ground material into the soil, which is material is lost due to the excavation, and we repair the surrounding soil or fill the surrounding material which is lost. By this technique we apply, and jet grouting is like that. We apply through grouting material applied through a pipe by a pressure, and this grouting material mix with the surrounding soil, and a hardened column-like structure is formed. By this way, we uh, improve the surrounding soil. So now we discuss about the objective of the grouting. So what are the objectives? And most of the case, it is common to all the ground improvement technique. Most of the case, it is common. So first one is densification to prevent or arrest the settlement and mitigate the liquefaction. You most of the case, the ground inflow technique is used to densify the surrounding soil, and also used to settlement and mitigate the liquefaction, or reduce the settlement or mitigate the liquefaction, and also used to soil solidification to increase the cohesion of the granular soil. That is bonding between the soil particle. To increase the bonding between the soil particle, we use this grouting technique. Then use to reduction of permeability and water control. That means the permeability of the soil may reduce due to the application of grouting. That means if we apply grouting to the soil, the void space is filled by the grouting material, and the soil pores are filled by grouting material, and permeability of soil reduced. Due to this reduction of the permeability, water would not is not flow to that region, and or we can say the region may be become waterproof, and also used to stabilize and reduce the expansion of the castle, and again used to compensation for lost ground and filling large voids. Additional support also used for additional support for existing. For this purpose, we mainly for use this grouting technique. Now we discuss about the suitability of the grouting technique. So it is said that the permeation grouting is suitable for cohesionless soil such as gravel and sand. That means the permeation grouting. That means we apply only grouting method through pipe through by gravity. This technique is mainly used for the only for cohesionless soil. That means gravel and sand. For salty sand or silt or clay, this method is not suitable. Or for rock also, this method is not suitable. Then the compa- compaction grouting is mostly used for sand, but sometimes also used for silt and clay. If the dissipation of excess pore pressure is permitted, that means if we allow the dissipation of excess pore pressure, if we even allow the drainage, then this method also used for the silt and clay also. And most of the time, each method, this compaction grouting method, is used for the sand only. Then the third one is hydrofracturing grouting. This method mostly suitable for sand, silt, clay, and often used for the compensation of the grouting purpose. That means this hydrofracturing grouting also used for compensation grouting technique also. So this so hydrofracturing grouting is mostly suitable for here for sand, clay, or silt. Then the last one is uh, jet grouting method, and this jet grouting method is suitable for all type of soil. That means it is used for clay also, it is used for sand also, it is used for gravel also, and sometimes it is used for the rock also. That means all kind of soil type. This jet grouting is useful. So last one point here is written here that permeation grouting, compaction grouting, and hydrofracturing grouting have also used for decomposed rock and fissure rock. That means uh, this permeation, compaction, and hydrofracturing grouting is used to decompose rock uh, or to improve the decomposed rock or fissure rock. Fissure rock in the same way, cracked rock. A decomposed rock is weathering rock. That means this rock is gradually decreasing its volume and converting into the soil particles. To stabilize that type of rock, or improve this rock, we use permeation. Most of the case, we use the permeation grouting, compression grouting, and hydrofracturing grouting. Now we have shown one chart based on the particle passing, that is percentage of fine and particle size. So based on the particle gradation curve, this curve is nothing but is called the particle gradation curve. So by this particle gradation curve, we discuss we discuss about the different type of grouting. That means a hot type of soil particle which grouting type is most suitable, we can easily identify by this chart. So here it is said that cement slurry grouting is mostly used for the gravel particle. That means up to that much of soil particles is the cement slurry grouting is used. And also it is shown that jet grouting is used for all type of soil particles. And here also see that permeation grouting is mostly used for sand and gravel. Chemical grouting is mostly used for sand, right? And hydrofracturing grouting, compensating grouting is used for sand, silt, and clay particle. And compaction grouting is only used for sand particle, or sometimes a little amount for silt and clay also. So by this chart, we can easily identify what type, where we use what type of grouting for different type of particle size. So now we come to discuss about the application, where we use this grouting technique most of the case. So first we discuss about densification gravel soil. It is already we discussed about it, and also used for the rising settled structure. That means if any existing structure is present, so we construct one structure. After few years, the structure is settled. One part of this foundation of the structure is settled down. That means to rise this existing structure, we use sometimes we use this grout under this existing structure and gradually rise the foundation and save our construction without any just destructive nature of technique. Then also use for control the settlement and use for underpiling of the existing foundation. Underpiling means to improve the uh, soil under the under the existing foundation. That means if the already foundation is present, and after a few years the soil below the foundation is degraded. To improve this soil, we use this grouting technique. Also used to support the excavation. That means if we excavate one tunnel, the tunnel wall is stabilized through this grouting also, or injecting the grouting material. So by this purpose also we use this grouting method. Then protection of existing structure during tunneling. I already discussed, and also used to mitigate the liquefaction. That means we liquefaction happen when there is present in loose loose sand, and water is not properly dissipated. And if we apply the grouting material into the soil, this void space of water is void space of soil is filled by this grouting material, and this further this soil is not allowed to water stay there, and liquefaction phenomena may be mitigated by this technique, grouting. Then control water, similar that first one is liquefaction, that it is reduce the permeability due to the induction of permeability, water not flow through the soil, so it is not hampering the existing foundation. So we control, by this way we control the water to flow into the soil. So now discuss about the advantages. So here it is said that it is used when we use this technique, the grouting technique, no other, no need to remove or replacement the soil of the existing structure or existing ground. So by only by injecting some chemical solution, we improve this soil. So, and also it is effective for underpinning and protecting the existing structure. That means we already discussed that if we apply the grouting material under the existing foundation, by this way we after a certain time this grouting material is mixed with the surrounding soil and hardened soil mass is formed. By this way we improve the existing structure, and also this technique is easy to access and operate within the constant pace. That means if the area of the improve area of the targeted area of our target area is very small, and no other technique is accessible to this area, then this method is mostly suitable, because only if you by only if you little equipments we improve this technique. The last one is advantage is low mobilization cost. That means when you need to move one, uh, we no need to move one point to another point. The cost of the mobilization, that means we if we move to one point to another point, the cost of the mobilization cost is very less by this grouting technique. Now we discuss about some disadvantage also. So it is said that the quantity of grout is hard to estimate. That means what amount of grout material is required to improve this soil. It is very difficult to understand. Then the effectiveness of the some application cannot be predicted. That means we cannot judge after the application of the grouting material, or we cannot predict how much this grouting material is suitable or improve our existing structure. We cannot judge. So then the area of improvement is sometimes uncertain, and uncertain routing may cause ground movement and distress of the existing. That means when we apply the grouting material, due to the pressure of the grouting material, the ground movement is happen due to the movement. If some existing structure is present here, the settlements may occur, and this existing structure may collapse uh, if the pressure is more than the allowable pressure of the soil. So it may happen during this grouting technique. Then certain chemical grouts may contain toxicity and have adverse impact to groundwater and underground environment. That means when we use chemical in this chemical is mixed with the groundwater and they may adverse the groundwater. We toxify the groundwater. And specialty contractors are required for the operation. That means no some skillful labor is required to input or to inject the grout into the uh, s- uh, into the soil. No ordinary labor is not suitable for worker is not handle this grouting technique. Now discuss about some grouting characteristics. Here it is discussed as groutability, stability, setting time, permeance, and toxicity. One by one now we discuss this characteristic. The first one is groutability. It is said that to obtain the satisfactory performance, grain size distribution should be known because it shall show the relationship between the grout particles size and the void dimension. That means this groutability, that means whether this grouting is applicable to the soil is perfect or not, it is mostly based on the grain size distribution. That means the particle size by the particle size distribution we uh, we find out what or identify what method is what type of grouting method is used in this soil. Then we also need to address the pumping pressure. That means the pumping pressure should not be larger enough for the particle of the soil to be disturbed. That means if when we apply the grouting through some pressure, the existing soil should not be disturbed. The grouting pressure is limited to 20 kilonewton per meter square. The quality of the grout must be sufficiently fluid to enter the soil quickly. That means the fluidity of the grouting should be maintained to enter the void spaces. The movement should not be too far. That means the when we apply the grout material into the grouting into the soil, the mobility of the grouting or movement of the grouting should not be too fast. If it is very fast, then the surrounding soil movement also happen due to the movement. Settlements may occur or ground subsidence may occur, and existing structure may collapse. The rate of injection of the grout depends on that means the injection rate of grout depends on the viscosity of the grout, permeability of the soil, and shear of the soil. By this way, we define the groutability of the material. Now we discuss about the suitability desirable properties of the grout. The suitable viscosity that means what type of uh, viscosity, what viscosity we apply when we apply, maintain when we apply this grouting material. So it is said that high viscosity is used for the coarse or moderately permeable soil, and low viscosity is used for fine soil of low permeability. Then also we need to adjust the correct setting time. It means the setting time should not be so very slow or also should not be very fast. We should maintain it. And then the maximum volume within minimum weight. That means the volume uh, of the grouting material should be maximum with minimum weight also. And also need to adjust the strength, stability, and durability. That means we need to identify the grouting strength and also stability and durability during our uh, application. And this grouting ability is defined by one ratio, which is called groutability ratio, which is nothing but D15, which is the ratio of the D15 by the D85. D15 is used for formation, that means already existing soil, and D85 is used for the grouting material. So D15 here it is a particle size at 15% of soil is final, and D85 is uh, sorry, D85 is the particle size at which the 80% of grouting the grout is final. So by this formula we find out the groutability ratio, and based on this groutability ratio we know about that whether this soil is suitable for this different grouting technique or not. So now we discuss about other characteristic, that is stability, setting time, permanence, and toxicity. So stability, the capacity of the grout to remain in a fluid state and not segregate into the separate component. So to maintain the stability, the capacitor should be remain in fluid state and not segregate into the separate component. And setting time. For setting time, the time required for the grout to be set into the cement mass or gel. Now, the setting time means the time required for the grout to set into the cement mass or gel. And it is discussed that early setting time cause difficulty to the ground reaching into its destination. That means if the setting time if the ground set very quickly, if we apply the grouting material through a pipe, if the grouting material set very quickly, and if our targeted depth is here, it may not reach to our targeted depth because it is already before reaching it is already set. And also the setting time should not be very late or slow. That means if we very slow, it cause grout being washed away if the seepage is occurring through the soil. That means if the setting time of the grout is very large, due to some rainy season or due to some water flow or seepaging of water, it may be washed out. So also the grout setting time should not be very large. Then another characteristic, permeance. Permeance means up to how much depth this grout material is penetrate into the soil. So it is said that the resistance of the grout process against being displaced from the soil voids with time. That means we already discussed that the uh, up to how much depth this grouting material is penetrated, it is discussed by this permeance. Now another characteristic is toxicity. The toxicity for toxicity, the capacity of ground to contaminate the groundwater coming in contact with it. That means if we apply different type of grouting material, whether it is toxic for our groundwater or not, we need to address this. Now uh, we divide this grouting technique based on the different grouting material. It means like suspension, emulsion, and solution. So suspension, grout particle in suspension in a liquid medium, and the suspension is made by cement, clay, or sometimes cement or water also. Emulsion, minute droplets of liquid in suspension. Then emulsion means when water or oil type of fluid is mixture, then something is created. This something is called emulsion. So uh, in emulsion, if we are grouting material is emulsion type, the minute droplet of liquid is always in suspension, and most of the case we use asphalt or bitumen with water as a emulsion. The last one is solution. So in solution, liquid homogeneous mixture of two or more materials is applied. That means two liquid or chemicals are a mixture, and this mixture is applied to the ground, and This is called solution grouting. And most of the case, this grouting is chemical grounds. Now we discuss one by one this grouting technique, different grouting technique based on the material. First one is suspension grout, and here we use the suspension with cement, grouting with cement. So it is said that it is unsuitable for the cracks or void wider than the zero point 0.2 mm. Then, if the void is more than zero point 0.2 mm, this method is not suitable. And usually used, this grouting is used formed by OPC and water. The mixture of OPC cement, ordinary Portland cement, and water. And water cement ratio should be maintained in between zero point 0.5 is to 1 to 0.5 is to 5 is to 1. And repeat hardening cement is used when the we apply this grouting when the ground into the flowing water. When we apply this grouting into the flowing water, repeat hardening cement is used. And when there is fissure rock, we apply the super sulfated cement. And also said that admixtures such as bentonite used to keep the cement particle in suspension. That means the bentonite, one of the clay particle or mineral we use during this suspension grout to maintain the cement particle in suspension. And the application of this suspension grout is seepage cutoff beneath the dam and groundwater control. That means we cut the seepage under the dam. We have, to cut the seepage under the dam, we apply this grout, and also to control the groundwater table, we use this suspension grout. Next is emulsion grout, and we use the asphalt emulsion. So it is said that anionic or cationic asphaltic globules are manufactured by choosing proper emulsifying agent, and the globules is sometimes 1 to 2 micrometer dia, along with water used as a grout to fill soil voids and rock fissure. The rock fissure of 10 uh, uh, micrometer size and medium fill can be grouted. That means, and slow setting emulsion generally chosen, they can travel longest distance into the material. So by this way, we apply different point. We apply this emulsion grout into the soil. Now we discuss about the solution grout, and most of the case it is chemical grout. It is called chemical grout. So it is said that the chemical grouts like silicate, acrylic resins we used in this solution grouting, and this solution grouting solidify by the chemical reaction. By only chemical reaction, this soil mass is solidified for this grout. And seepage is used for seepage barrier stabilization of soil around the tunnel. The principle of injection, permeation of grouting. That means we use this principle of injection is used for this permeation grouting. And by this way, we apply the solution grout into the soil. Now here we uh, show two types of system which is applied for the chemical grouting. That means solution grouting. We apply two method. One is one shot method, and another one is two shot method. For one shot method, we apply at only one times. Solution we apply only one time. In two shot method, we apply one chemical, and after some time we apply another chemical. By this way, we improve the ground. So we discuss here by tabular form. We discuss the one shot system and two shot system. So it is said that in one shot system, all chemicals are injected together after pre-mixing, and in two shot system, one chemical is injected followed by injection of a second chemical which reacts with the first to produce a gel which subsequently hardens. And second point is that in one-shot system, setting time is controlled by varying the catalyst concentration according to the ground concentration, water composition, and temperature. And in two-shot system, it is said that this is slower or require this is slower or require higher injection pressure and more closely spaced grout hose. So by this way, we applied one-shot system in the ground, also applied the two-shot system into the ground. Now we discuss the grouting procedure. How we that means how we apply by what method we apply to select the grouting techniques in the field we discussed now. So it is depending on the material to be grouted. That means what material should be improved by grouting technique. It is next to depend. That means whether it is rock, natural soil, or field to improve, and it also depends on the its quality. That means this material quality, existing ground quality, and also the purpose of grouting. Well planned procedure, purpose of the that means for what purpose we use this routing technique. Whether it is control the settlement of the existing structure or improve the existing structure or control the cut or the seepage of the under the depth. So by this way we select our routing of in the field. So first one is we are discuss about the ground investigation. First is investigation. Then we select find out the ground holes pattern. Then routing plant and equipment also we select, and then routing sequence also discuss. And last one is routing method. What method we apply? So the first one is ground investigation. So most of the case, the preliminary step is ground investigation. So it provides information regarding the ground, whether it can be grouted or not. Choice of grout types or choice of grouts, that means types and amount, what type of grout is applied and what amount which is applied. And also sometimes it include a geological survey, drilling boreholes, collection of samples for laboratory test. So first step is ground investigation. By this way, we investigate the ground. Now we discuss about the grout holes pattern. And most of the case, it is based on the nature of the work, number of the drill holes, depth, and pattern to be defined. So by this way, we define the depth and pattern. The follows it follows a grid pattern such as such that the radius of penetration is sufficient to cause slight overlapping between the existing holes. So we know that the effectiveness of the grout tin material we could not find out. So for that, is properly we cannot properly find out. So for that, when we apply, theoretically we find out this. That means up to a r radius or up to some radius, a circle, we apply the ground. But theoretically, we find out. But in practical, in many factors come into the picture. For that, this circle may be reduced. For this precaution, we apply the uh, grouting radius or the grouting radius should be sufficiently slightly higher or overlapping the existing hole. So by this way, we apply the grouting into the field. So in the two holes mainly apply. First one is primary holes, and second one is secondary holes. So in primary holes maintain one grid pattern. You can see here it is triangular pattern here. If you can see into the picture, it means Here it is said that it is triangular pattern. Like this way, it is triangular pattern. So, but after applying this grid pattern, some space is remaining. So to fill this space, we apply and again another hole or make another hole to apply this ground. This hole is called secondary hole. So to fill the uh, space which is remaining. Now we discuss the grouting plant and equipment. So different equipment is used during this grouting. The first one is measurement tank to control the volume of the grout injected. Then mixture to mix the grout ingredient. Agitator to keep solid particles in suspension until pumped. Pump to draw the grout from the agitator to deliver to the pumping line to control fittings, to control the injection rate and pressure so that the hole can be regularly blend with the water and thin ground, and piping connected with the ground. By this equipment, we apply the grouting into the soil. That means measuring tank, mixture, agitator, pump, control fittings, and this piping connected to the ground. Here one picture is shown for different equipment is used uh, in the during the grouting, and also some uh, another mixture. Another picture is shown for the mixture. Different plan view, cross section view also shown, and here also show the motor also. One picture is shown for the motor, cross section also show, and plan view elevation also here. So this picture is nothing but the equipments used in this routing techniques. Here it is shown. Now we discuss one by one different types of grouting method. That is permeation grouting, jet grouting, compaction grouting, whether it is suitable, how it is applying, and like the hydrofracture grouting is like that. So, so first one is permeation grouting. Then we already discuss little bit about the permeation grouting. Please wait few seconds. So permeation grouting. Grout fills the pores without any volume change. Includes cement grouts, bentonite grouts, and chemical grouts. That means through gravity only, without any pressure, this grouting technique is used. Grouting into an open hole of self-supporting ground through a pipes at the surface, through an injection pipe held in a place in a hole or casing by a pacemaker. Pacecar, packer. So by this way, we apply permeation and grout into the soil. You can see here only through a pipe, grout in fissure or grouting in the pipes in soil. This is applied for the soil. This is applied for the rock. Application of the permeation grout. Mostly used for it is used for seepage control and for the soil solidification and sewerage. For seepage control, for making the vertical seepage barrier uh, beneath the hydrostructure, this permeation grouting is. Also, to stoppage of seepage through the joints of underground structures such as tunnel, lining, and basement wall is also used. And for soil solidification and civilization, around the tunnel and shaft, this permeation grouts also used. Now we come to compaction grouting. So it is said that a good option if the foundation of an existing building requires improvement. Since it is possible to inject the grout from the side or at an inclined angle to reach beneath the building. That means this type of compression ground mostly used for the existing structure to improve the soil under the existing foundation and raise the foundation level up because due to this soil degradation sometimes after the construction soil may be degraded due to some reason and there may be settlement happen. So to improve this existing structure, this compression grout mostly used. And this compression grouting is a bulb-shaped grout mass is formed. During this compression grout, this bulb-shaped grout mass is formed, and most of the case it is used compression grout as used as a soil cement grout. And this is used. It can be performed as a pre-treatment before the structure is built. Sometimes that means sometimes we also use this type of to as a pre-treatment before construction. Now come to the application. It is mostly used for the densification of the loose strata, that means underlying dense soil beneath the foundation or loose or floor slab jacking. Floor slab or slab jacking. For this compression ground mostly used. Also used for filling the large underground cavities, densification of collapsible soil, densification of the soil showing the organic degradation. For this purpose, this different purpose, this compression grouting is used. Now come to the jet grouting. So it involves the injection of low viscosity liquid grout into the pore spaces of granular soil. This creates harden the soils to replace loose liquefiable soil. Jet grouting is used as a replacement technique in which the soil ranging from silt to clay and weak rock can be treated. This method consists of lowering a drill pipe into a 150 mm dia bore. The drill pipe is specifically designed which simultaneously conveys pump water, compressed air, and grout soil. Three system of jet grouting is applied. One is single, double, and triple. So here three picture is shown. First one is for single jet grouting, second one is double jet grouting, and third one is triple jet grouting. So first single jet grouting only we apply the grout material only. But in double jet grouting, we apply grout and also compressed air also we apply. And in triple jet grouting, we apply water, air, compressed air, and also the grouting material. So by this way, different three ways we apply we apply the grouting material. So by jet grouting technique. Now we discuss about the application of the jet grouting technique. So it is mostly divided, majorly used for the groundwater control. Most of the case, the jet grouting is used for the groundwater control. That means to prevent the flow either through the sides or into the base of the excavation, or also control the groundwater during the tunneling to prevent or reduce the water seepage through the water retention structures such as the dam or the flood defense structure, also to prevent or reduce the contamination flow through the ground. So these different ways, by this different way, we control the groundwater through this jet grouting. Another application is for use for the movement or control the movement. So it is used to prevent the ground or substructure movement during the excavation or tunneling. Also used to support the face or sides of the tunnel during the construction or in the long term. Increase the factor of safety of the embankments or cuttings. So it provides the support to piles or walls to prevent or reduce the lateral movement. and then it is also used to as a support. That means it is used as an underpinning building during the excavation or tunneling. It is also used to improve the ground to prevent the failure through the inadequate bearing. Also used to transfer the foundation load through weak material to a component structure. And also used for the environmental purposes. That means it is capture the contaminants in the ground to reduce or to prevent the contamination of oxide or into the sensitive water system. Also, it is used to provide lateral or vertical barrier to a contaminated flow, introducing reactive material into the ground to treat specific contaminant by creating permeable reactive barriers. So, this jet grouting technique have wide number of application. One is control the groundwater, second one the control the ground movement, also used as a support, also used as a environmental reduce the environment purpose also, also use the environmental purpose also. So this is most important, one of the most important technique for the grouting, that is jet grouting, and also this jet grouting is used for uh, uh, wide range of soil particles. That means any type of soil to improve this jet grouting may be used. Now we take 5 minutes break. After that, we discuss the further different grouting techniques, and we discuss one problem assignment. Then we conclude. So now we take 5 minutes break. Don't leave the session. Stay on the line. I will join after 5 minutes. Now, again, welcome to this session. Now we discuss the further method, another method of this ground improvement, this grouting technique. So, we need to very quick because we have I finished this slide. It's very long slide, and after that I will try to solve. If time permits, I will try to solve previous assignment problems. So we start a session again. So another ground improvement, grouting technique is soil fracture technique, or we can say hydraulic soil fracture technique. So this technique is a root-like zones of grout material is formed in the soil. Slip pipe grouting technique is used in this technique and used for restoration of vertically or fed tilted building. That means when a building is tilted and to restore it, to raise the building, we use this type of grouting technique. So here some figure is given. Most of the case this figure is for dam or argent dam. So to cut the seepage, most of the case below the dam, most of the case we use this type of grouting technique. So we can say first here it is grouting cutting. Here you use the jet grout cutoff. Here you use the blanket grouting or deep grouting cutting. Uh, Other picture also here that here one tunnel is there. Improve the surface above the tunnel. We use this jet grouting like that way and improve the surrounding soil. Also used to densify the underground structure or underground soil by this grouting also. And once floor slab is present, below this floor say some loose material is present. To improve increase the strength of this loose material, this grouting method is used. There another other pictures also here shown here for this jet grouting. That means we by this bulb-like structure. That means compaction grouting we apply by this bulb-like structure. We improve the ground. Or one picture also here given there. On existing foundation is given below this existing foundation through a pipe, uh, and by grouting we improve this existing soil, uh, and improve the ground. Now we discuss the theory of induction. That means by how the pressure of the injection pressure, the radius of the influence zone of the ground material, and the height of the grouting pipe, we discuss one by one now. So first one is injection, theory of injection. So we can say one there is soil existing soil is present and the groundwater table is up to like that, and we need to improve uh, the soil below the groundwater table. So then the one pipe is inserted, and below through this pipe the ground material is injected by some pressure, and we can say the pressure head is first before the applying the grouting is H max, and after some times this pressure is reduced and come to this height of the groundwater table, and due to the apply of this grouting material, one the through this pipe this grouting material is spread to the surrounding soil, and we can say the maximum distance it is covered is R. That means one circle is formed up to that much. We can say the grouting material is penetrate into the soil. So it is a theoretical base. That means some assumption we can make to find out this. The first assumption is having this ground is uniform and isotropic. Most of the case we assume that, and also assume that ground is Newtonian fluid. We know that in fluid mechanics, we studied the different types of fluid. One is Newtonian fluid, another one is non-Newtonian fluid. So, Newtonian fluid is proportional to the shear strain, rate of shear strain. So, but non-Newtonian fluid is not proportional to the rate of shear. So here we, so the assumption is here this the ground material is Newtonian fluid, but most of the case it is not true. So then another assumption is that the grout is injected from the bottom of the pipe. It means at the bottom only pipe this grouting material is injected. The grout to penetrate to a radius by r by a spherical. That means we assume that one sphere is formed when we apply the grout material through a pipe. Due to spray, the radius of the sphere is r. We assume. So now we apply Darcy's law. Darcy's law means is Q is equal to A into K into I. A is here the cross section area, K is the permeability, I is the hydrographic area. And we know that volume is equal to Q into that is discharge into time. So if we apply this Darcy's law, we can find one formula, that is pi r square kg t minus dh by dr, where I is here is dh by dr, k or a is here is pi r square. Pi r square is the surface area of the 4 pi r square. Sorry, 4 pi r square is the surface area of the sphere. So now we apply integration, then we come to the formula, one formula, that is h is equal to Vg by 4 pi kg uh, T into 1 by R plus C is one constant. So H is here the height of height is any arbitrary height from where we apply uh, this grouting material into the soil uh, up to it, and the soil this grouting. And R is the penetration radius. That means up to what much distance this grouting is penetrated. We assume it is smaller. Now we apply the boundary condition here. The first boundary condition is that we consider R is equal to the R naught and H is equal to the H naught. The second boundary condition is the R is equal to the capital R, H is equal to the HW. Here HW is here the height of the groundwater table from the routing point, and del HW is the head difference between the routing pressure and the water table. After putting all the boundary condition, we come to one formula here, Hmax minus Hw. That means del H. And if we replace the Vg by the volume of the sphere, that means 4 by 3 pi r cube into Np. Np here nothing but here the porosity of the soil. That means the how much void is present is here, and we replace this Vg by this formula. We come to then after this formula. And after simplifying this formula further, we come to this final form of this formula. That means del SW is equal to R cube into NP divided by 3 kg T in divided by R naught, where R is the maximum distance or radius of this grouting material is covered. NP is the porosity, Kg is the permeability coefficient of this grouting material, and T is the time taken for this penetration, and R naught is the radius of the sphere grouting material. So now we modify this formula by for our uh, different needs. So first we modify this formula for finding out the t, that is time, and then we modify this formula for finding out the radius of the penetration of the grouting material. Mixing radius of the grouting material. All the above formula, which I till now I discussed, which is based on the assumption that this is for the spherical flow. That means uh, after applying the grouting material, one sphere is formed. But sometimes this sphere is not formed. We sometimes here form is cylinder is formed or cylinder. For that, we modify our formula based on the cylinder. So we modify the t time and also modify the radius r. So by these two formula, we easily find out the time and radius for the cylindrical pattern or cylindrical shape of the ground. One point is here is given that permeability of the soil ground is is depends on the viscosity of the ground and can be estimated by this relation. That means Kg is equal to K into mu W by mu G. And we can further it modify by the K by beta G, beta suffix G, where K is the porosity of the soil, sorry, permeability of the soil, and mu W is the viscosity of the water, and mu G is the viscosity of the ground. And beta G is the ratio of the mu G by mu W. So one table is given for different grouting material. This week what type of material is used and how much it is specific oxide, strength, and relative cost. And by this table, we can easily find out. That means type 1 cement has high viscosity, low toxicity, and water cement ratio is 2:1, high strength, low to. And by this way, different we find out by this table, we find out the uh, 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 for different material. We find out the different characteristic by this table. And this table is given by Elias et al. In 2006. Further, one chart is given for different types of grouting material based on the viscosity and concentration or solid. So it is given for bentonite, sodium silicate, chromium lignite, resin ground, and acrylamide based ground. And again, one chart is given for based on the permeability coefficient and the uh, size of the grain. And based on that, different routing material is used with the new chart. Now, one we come to that another grouting technique is compaction grouting. So in compaction grouting, we inject a stiff or low mobility grout to apply pressure on the surrounding soil and replace the soil particles. A grout bulb is formed around the grouting source. If the grout bulb is simplified as a sphere, the pressure within the bulb is equal in all directions but decrease in the soil rapidly from the edge of the spherical bulb to the zero at the certain distance as shown in figure. That means if we apply this grouting material, if you consider it is formed one sphere, then this sphere is create pressure on the surrounding soil. And it is said that the pressure is zero if the distance is reached to the R. That means reach to the maximum distance. That means this pressure is continuously decreasing from the surface of the ground material to a distance of the surrounding soil. And it is said that RP is for compacted soil is R is in between the RP less than equal to R less than R naught. That means that much. That means that much is for compacted soil, and for grout is used for that much. And if the grout is solidified, and after solidifying, this grout is creates some pressure on the surrounding soil. Due to this pressure, the surrounding soil is compacted, and further the surrounding soil is modified. By this way, we improve the ground. And it is said that under the applied pressure, the soil within the influence range deform and accumulate a volumetric strain epsilon V. The volumetric strain can be calculated based on the volume of the ground, that is V suffix G, and the initial volume of the soil within the influence range, that is V suffix I. Based on this and applying the strain theory, I find out that epsilon V is equal to the volume V ground divided by volume of the initial volume of the surrounding soil. And one term, that is soil bulk modulus, we find out, we know that soil bulk modulus is equal to the pressure divided by strain. So based on this formula, we find out the soil bulk modulus, and here P suffix G is the ground pressure. By this way, we find out the soil ground bulk modulus during the ground. Now we find out the change in unit weight due to the is applying the grouting material. How much uh, due to the applying the grouting material? How much unit weight is changed? We find out that del gamma is equal to the WS, that is unit weight of, sorry, total weight of the soil, divided by the change in volume minus the initial unit weight. So by this way we come to this formula, and after that we find out the percentage change in the unit weight. That means up to what percentage this unit weight is changed. And then we come to this formula, that is percentage change, that is change in unit weight due to initial unit weight is equal to nothing equal to the pressure of the gravity material divided by the soil bulk modulus, and we find out that and by this formula we find out the percentage change in the unit weight. Now we find out the force which is applied during the jet grouting or during the formation of the jet grouted column. So the erosion of soil by jet grouting mainly relies on the impact force produced by the ground. The force of the jet is in air can be expressed as P is equal to rho g Qg into P, small p, where rho g is the density of the ground, Qg is the distance of the ground, and P small p is the average velocity of the jet ground. And if you replace the Qg is equal to the small b into N naught, where N naught is equal to the cross sectional area of the nozzle, then we come to that the total force during the jet ground is equal to the rho g into N naught into V. So by this formula, we find out the impact force during the jet ground. Now we discuss about the design consideration of the permeation grouting. So for designing of the permeation grout, we first consider the groutability. For to measure the groutability, we ensure that the groutability of the grout into the soil or rock based on the two parameters, which is proposed by the Mitchell and Khati based on Tarjargi's filter criteria. So this two men, Mitchell and Khati, modify the Tarjargi filter criteria and come to the give two parameter for groutability. One is for soil and another one is for rock. So first one is for soil. For soil, the groutability is equal to the D15 of soil divided by D85 of the ground. And for groutability for the rock is equal to the TF divided by the D95 for ground, where TF is the width of the fissure in rock. Here D15 here is the percentage of the soil particles finer than the 15%, and D85 for the ground is the percentage of the ground particles finer than the 85%. And like that, D95 is the percentage of ground particle size which is finer than the 95% for the ground. So one conclusion is given here, or point is given here that cement grout, when you apply the cement grout, the groutable to cement grout is in soil when uh, that means the cement grout is groutable in soil when the NGS, that is groutability is greater than 11, but consistently groutable when the NGS is more than 24. That means this most of the case it is used for when the groutability, cement groutability when the it is greater than 11, but for consistent it is more than used when the groutability is more than 24. Then only we use the cement grout. But in case of clear cement grout, when we apply in the soil, it is groutable when the NGS is greater than 5. In rock, cement grout is groutable when the NGR is greater than 2, but consistently groutable when this NGR is greater than 5. So 2 point is note down during when we apply the cement grout in soil and on in rock. So based on this groutability ratio, we find out whether this cement grout is applied to the rock or not, uh, like that. So one table is given for the application of grouts in generation. It is given by FTS in 1991. So different types of grout material is here is shown in this chart, and it is based on the strengthening and water weathering, whether it is used for the strengthening or whether it is for weathering, water tightening, and whether it is used for the only for normal field condition or limited by the cost. And this chart also based on the permeability also soil. So like that way different material is given. Cement is mostly used for strengthening purpose and when used for mostly when the permeability of the soil is greater than 10 to the minus 3 to 10 to the minus 1. Like that way different types of material is given here and when it is suitable, whether it is suitable or when it is suitable, by this chart we can easily identify. Now we find out the required height for this jet grouting in the for the nutrient fluid, and we consider that the soil is uniform isotopic, and we find out the penetration radius also. R we sorry radius R consider the penetration radius R as spherical flow is formed, and we find out the head difference, which is given by Raphael and Green in 1961. By this formula, that is del HW is nothing but head difference is equal to Qg by 4 pi k into B beta suffix g into 1 by R naught plus 1 by R plus 1 by R whole plus 1 by R. So by this formula, we easily find out the head difference for the jet grouting or nutrient fluid in uh, spherical fluid. If we consider the cylindrical injection, so then we modified our formula R naught, and uh, it is replaced by zero point 0.5 root over L into D. Whether is the length of the cylinder and D is the diameter of the cylinder. So by this way, we easily find out the head difference of the injection pipe during ground. After that, we easily find out the grouting pressure during the injection. So it is given that the grouting pressure is equal to the gamma W into HW plus del HW minus gamma G into HGP. That means gamma W is the unit of the water, HW is the height of water table from the point of grout. That means if we apply here and water table is up to there, then this height is HW, and is del HW is the head difference, which is find out by this formula. Gamma G is the unit weight of the ground material. HGP is the height of the ground material injection from the injection point. It means if we apply this grouting material through pipe from this point and we reach up to this point, this is the edge from this point. This you can see in the drawing. All the above terms is discussed here. No need to further discuss elaborately. Now, we further by this formula, further we modify uh, uh, to find out the different other parameters. So uh, this del HW, if you modify this del HW, you can find out the time period required or time required to penetrate the fully radius R. So it is given, it is found out by this formula, and here it is given that NP is here it is porosity. One point is given here that it is recommended that permeation grouting be used in gravel or sandy soil with less than 15% silt and clay. Otherwise, uh, it may take too long to inject grout as a permissible pressure. That means when we apply the permissible grout through a pipe, the soil should be permeable in nature, and the that means the nature of the soil should be portionless. That means gravel and sandy soil. If any silt sand or clay present, the percentage of clay should be less than 15%. If it is greater than 15%, the pore pace is reduced and more time is required to penetrate into our targeted soil. So this method is only suitable for when the penetration area, sorry, when the soil is contain less than 15% seal and now this above formula is modified for the Birnbaum fluid. We till we discuss about the neutral fluid. We know that we assume that the whatever grouting material we use, all this grouting material should be neutral fluid. But in the real case, this grouting material is this grouting material is not the neutral fluid or is not maintaining the theory of neutral fluid. So most of the case it is non-neutral. So here we discuss about the one non-Newtonian fluid is Wenger. So when by this when we apply the Bingham or consider the Bingham fluid, we modified our formula further based on some requirement. So it is said that a minimum hydraulic gradient is needed to overcome the yield strength if a Vienna fluid is. For the one formula is given, that means a minimum hydraulic I minimum is equal to 4 tau S divided by G into gamma G. So when we apply the minimum fluid, it should be considered that the minimum hydraulic resistance should be overcome the yield strength. Then only we apply or use the minimum fluid or use our formula. So it is said that the minimum hydraulic gradient is equal to the 4 tau s into d into gamma g. So tau s, where it is tau s is the yield strength of the beam of fluid, d is the effective diameter of the pore, and gamma g is the unit of the grout. So one point is made here that the yield strength of the typically chemical grout, which is nothing but neutral fluid, and also for 5% bacterial substitution, which is Birnbaum fluid, and for 0.67 water cement ratio grout are 0, 2.3, and 4 Newton per meter square ratio. That is for chemical grout, where most of the case it is neutral fluid, yield strength is 0. And for bacterial suspension, which is nothing but Birnbaum fluid, the yield strength is initial yield strength is 2.5 Newton per meter square, and for 0.67 water cement ratio, the yield strength is 4 Newton per meter square respectively. Now come to one formula to find out the effective diameter of the pore. So this formula is given by Kozny. So it is also known as the Kozny's equation to find out the diameter of the pore. It is given that d is equal to 2 into root over 8 into mu k into k divided by gamma w into n. Where mu k is here the viscosity of the grouting material, k is the permeability of the soil, uh, gamma w is the unit of water, and np is the porosity of the soil. So based on this formula, one chart is given for this behavior fluid, which is varied with permeability of soil, yield strength, and hydraulic rating. By this chart, we can easily find out the soil hydraulic gradient for this different soil permeability. Also find out the hydraulic yield strength of the behavior fluid. Now we find out the allowable grout pressure. So when the grout is behavior fluid, it requires much higher grout pressure. The injection pressure should be limited to avoid the ground heat. Allowable injection pressure can be estimated, that is PGA suffix GA is equal to 100 into alpha suffix P into P plus CGS into beta GM lambda C into Z. By this empirical formula, we can easily find out the allowable pressure of the surrounding soil. So we know that when we apply the being fluid, the higher pressure is required. But if we apply the higher pressure and if it is overcome the allowable pressure, then there may be created ground heat, which is not suitable for our ground. That means due to creation of the ground heat, surrounding soil may be disturbed and if there any presence of existing structure may be collapse. Maybe collapse. So here it is given that PGA is equal to the ground pressure, allowable ground pressure. Alpha P is equal to the Schuster factor, which is typically in between the 1 to 3. CEGS is equal to the grouting sequential factor, which is in between 1 for primary, 1.25 for secondary, and 1.5 for tertiary grouting. Beta GM is equal to for the grouting method factor, 0.84 for downstage and 0.6 for upstage. Lambda ST is equal to soil characteristics factor ranging in between the 0.5 to 5, and Z is the depth of the injection point from the ground. So by this formula we can easily find out the total allowable pressure which can take the ground safely. Now here one point is given that the estimated allowable ground pressure should be verified in the field by performing the ground trialing test. That means before starting our grouting technique, some trial tests should be made. Due to this trial test, we can easily find out or estimate the total allowable pressure, whether it is more than our ground pressure or not, or whether it is less than. If it is less than, then it is suitable. If it is greater than our allowing pressure, then that then the ground heat may be produced due to the changing volume of the due to the change of ground volume. One graph is given. By this graph, we can easily find out the total allowable pressure of the surrounding soil. Now we find out based on this formula, what another this given fluid, another formula is given to find out the limited penetration radius. That means up to how much distance it is, up to how much radius it is traveled during this routing. So it is given that RL is equal to the gamma G into HL into D divided by 4 tau s plus RL, where HL is the height from where it is applied to the point, the ground through the pipe, and D is the port diameter, TS is the L stem, R naught is the radius of the injection pipe. And also you can find out this HL, which is limited grouting here by this formula, which is PGA plus HT gamma G minus HW gamma W divided by gamma G. By this formula, you can easily find. Now, one another formula is given by at FTS 1900 for finding out the penetration radius, which is given by equal to the R is equal to the root of R Vg, that is volume of the ground, divided by the Np by Lg. Np is the porosity of the soil, and Lg is the thickness of the injected section of the pass lane. That means up to what depth this grouting material is penetrated. If we say it is from the cylindrical pattern, then the length of the cylinder is the Lg. You can see. That means up to how much depth it is this grouting material is penetrated. This is nothing but Lg. Another scientist, A et al. 1994 pointed out that actual injected ground volume per pass may be less than the calculated using the above equation because the ground may not fill all the voids and the water in the soil has occupied some of the voids. That means, in fact, theoretical, what we find out it is not applicable in the field because in field the actual volume of the ground should be less than our theoretical volume the because the ground may not fill all the void. That means the void space may not be filled by this grouting material. And also, when we apply this grouting material, sometimes this void space may be occupied by the water. So, by these two reasons, the actual volume of the routing is reduced. So, we modified our formula to multiply some correction factor. So, if we consider the one cylinder formed during the grouting, that is Vg, is equal to the pi r square into Lg, and if we and apply for void space, we multiply it with the porosity. So by this theoretical way, we find out the total volume of the grouting material. But in the field, one correction factor is needed, and if we multiply this correction factor with the actual theoretical volume, which is here it is V suffix V. So one table is given for finding out this correction factor for different types of soil. For here it is given that for clay, silt, and fine sand, correction factor is equal to the 0.3 to 0.5. For medium to dense sand, correction factor is equal to the zero point 0.5 to 0.7. For gravel, it is equal to the zero point 0.7 to 1, and for collapsible loess soil, it is equal to the zero point 0.5 to 0.8. Now, we discuss about the ground hole pattern and spacing. In field, what pattern is used and how much spacing is given, we discuss now. So most of the case we use the two types of pattern. One is triangular pattern, another one is square pattern. So it is said that the ground hole pattern of spacing for permeation gradient, all the above we discuss here is either for permeation or for jet gradient. So here the pattern is given for the permeation gradient, and it is said that it should be the ground hole should be for permeation, it should be based on the ground penetration radius, and the complete coverage of the grout area within the improved depth. That means this pattern, whole pattern should be depend on the grout penetration radius and coverage of the grout area within the improved depth. And depending on this application, grout holes may be arranged in a one row or multiple row. That means, depending on application, these grout holes may be arranged in a one row or a multiple row. So, for one row of the grout hole shown in the figure, the effective thickness of the grout area can be calculated as follows. That means, when we apply this grouting only for one row, that means like this way, like this way, how much effective thickness we find out by this formula. And we modify this formula and we come to that this effective thickness B here is equal to 2 into root over R square minus S square by 4, where S is the spacing between these two grouting points. And we can easily find out, to modify this formula, we can easily find out that. So here it is given that pattern, two pattern, one is triangular pattern and another one is square pattern. So if you when we apply this triangular pattern, which is best suited for this grout, any grouting technique, because it is cover all the area of the surrounding soil. So no need to require further applying any grouting point. So it is cover all the area of the surrounding. But when we apply the grouting in square pattern, two stages is needed. First one is primary stage, and second one is secondary stage. So in primary stage, we apply this grouting in square pattern. After that, in the middle, one void area is remained. So to improve this remaining area, we apply another grouting point. So by this way, we improve our soil in square pattern. So same one point is given for multiple rows. That means more than one rows we use here, like in square pattern and triangular pattern. So it is said that for two rows of ground hole, two pattern as shown in figure can be used. Triangular pattern includes all primary holes, while square pattern there that means no need to use secondary holes. But when we use square pattern, requires primary holes and a secondary holes to cover all the improved area. And it is given that for triangular pattern, the horizontal and vertical spacings are 1.8 r and 1.5 r respectively. R is the radius, maximum radius of penetration of the routing material. If you consider the cylinder or square. For square pattern, the horizontal and vertical spacing are both for both is 2r, and there is a secondary hole in the middle for every four primary holes. Typical grout spacing, grout like that way we can find it. So one spacing table is given for this grouting tool, which is given by F F test in 1991. So it is said that for when we improve the soil below the 20 meter depth, then for fine sand the spacing should be zero point 0.8 to 1.3 meter. For sand and sandy gravel, it is in between the 1 to 2 meter. Like that way, we can find out also for rock depth less than 25 meter, the improved area for the rock depth is less than 25 meter. For fine crack, the spacing is 1 to 3. For open crack, its spacing is between 2 to 5. Based on this table, we can easily find out the spacing for different material for different depth. Now we try to solve one problem, and it is the last problem in our slide, and also the last of this PPT. So now we try to solve this problem. So solve it. It is said that at a site or a site, a layer of loose medium sand with D15 is equal to 0.09 mm exists between 5 to 6 meter. The groundwater table was at a depth of 3 meter below the ground surface, and the permeability of soil is 0.9 mm per second. It was decided to improve the site by injecting or injection grouting using silica gel grout having a range of diameter 1.2 to 2 micrometer with D85 is equal to the 1.8 micrometer. Viscosity of soil is given that 6 centipoise and unit weight of water is given at 10.8 kiloliter per meter. The grout if the ground injection is flat at a rate Qg is equal to 1.25 meter cube per hour, determine the required ground hydraulic head and the ground pressure. Assume radius of ground penetration R is equal to zero point 0.3 meter and radius of injection source R naught is equal to 0.015 meter. So we have to find out the hydraulic head required. Uh, Also, we have to find out the ground pressure also by this data. So, try to solve this. So, first, we consider that several issues like soil type, toxicity, and cost. Supposed silicate solution is used for grouting. So, and we know that this silicate grouting solution is 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 come under the neutral free. So no need to apply the formula for the behavior fluid. So we only apply the formula for the neutral fluid. So first we find out the groutability ratio, whether it is suitable for grouting or not. So the groutability ratio find out the D15 of soil divided by D85 the ground. It is one correction is here then it is D85. So by applying all the or by putting all the values, we find out that the groutability is common to 50. And we know that for soil, when we apply the soil cement, the groutability should be greater than 24. And here it is will come about 50, which is also greater than 24. So the soil is groutable. Now we find out the head difference, that is del HW by this formula. After putting all the values in this formula, we easily find out that the del W HW is equal to the 12.99 meter. Now we assume that uh, now the injection fluid from the surface is equal to the from the ground for the surface is equal to the point is equal to the 5.5 meter. How it is coming? Uh, we know that the improvement zone is in between the 5 to 6 meter. So we simply average these 5 and 6. So it is come about 5.5 meter. So by this formula, we easily find out the injection point from the surface is equal to the 5.5 meter. And we assume that the head of the ground pipe above the ground is 1 meter above. So then the HGP That is HGP is here is the limited height of the grouting from the surface is about from the injection point is about 6.5 meter. So that means on 5.5 plus 1 meter. And now we find out the HW, that is from the injection height of the groundwater table from the injection point. So it is come about 5.5 minus height of the water table from the surface. So it is come about 2.5. After that, we find out the pressure required for the grouting or injection of the grouting. So by this formula, that is Pg is equal to rho W into HW plus del HW minus rho G into HGP. By this formula, we can easily find out, and it is coming about 80.5. Now we find out the whether this 80.4 pressure is suitable for our ground or not. We can find out. So we know that the silica solution is a neutron fluid, so no need to find out the yield strength, and we know that the yield strength is zero. So we don't need to modify our formula for the Greenwood fluid, and we directly put our formula for the finding out the allowable grounds, and find out that, and we consider all the value as a, that means alpha p is equal to 2, p of surcharge is 0, cgs for grouting is considering for primary is 1, beta gm is for grouting method is considering for point 0.8, and soil characteristic is considered as 1.5. We easily find out the allowable pressure of the soil, and it is coming about 220 kPa. So our grouting pressure is about 80.5 kPa. So it is less than the 220 kPa. So the soil easily take care of this grouting pressure, and no, there is no heaving created, and it is safe for this type of soil. So by this slide, we uh, finish our grouting technique. Now we try to we discuss about the in this session we discuss about the different types of grouting, what is the grouting, different types of grouting, whether is applied, and also discuss about different grouting theories for neutral fluid and behavioral fluid, and we also try to solve one problem. Now we try to solve previous year assignment problem. So in a previous assignment, it is it now is solved. And first question is here is that objectives of a grouting are densification to prevent the or arrest the settlement and mitigate the liquefaction soil, uh, solidification to increase the cohesion of granular soil, reduction of the permeability and water. So the correct answer is here is all of the above. So second question it is said that in the previous question probably said that the soil type suitable for the permission grouting. And we know that the permission grouting is mostly suitable for questionless soil. The correct answer is here in option. The third one it is said that the soil type suitable for jet grouting. We know that the jet grouting all type of soil is applicable. So the correct option is here is option D. Option 4, it is said that grouting pressure is generally limited to up to what up to 20 kPa. The correct option is here is option C. Option question 5 it is said that rate of injection of grout depends on viscosity of the grout, permeability of the soil, or shear strength of the soil. So we know that this rate is every option is correct. So the correct option is here is option D. Now Question 6 is tell about that as correct assumption for the theory of gravity. So we know that first option is given here that the ground is anisotropic, which is wrong. Consider the ground is isotropic. Second one is ground is nutrient fluid, which is correct. Third one is given that ground is injected from the top of the pipe, which is wrong. The assumption which is given there at the bottom of the pipe, which is correct. So the correct option is here, option B. Now one problem is given here in option 7 that a soil has a particular size corresponding to 15% passing, that is D15 is given is equal to 0.1 mm. To have consistently groundable in the rough soil, the cement grout ratio, uh, the cement grout the groutable ratio is given there 25. So find out the particle size for the D85 or 80% passing. So we know that the groutability ratio is equal to D15 by D18. D15 for soil and D85 for ground. So we can easily find out by this formula the D85 is equal to the 0.04 mm. So the correct option is here is option B. So in question 8, it said that find out the compaction. It said that compression grounding with the grounding pressure is given is 20 MPa. Inject stiff grout in the ground to densify the corrosionless soil at 5 meter below the ground surface. The soil bulk modulus at the depth is 20 MPa. The percentage of unit weight increase within the compacted zone is. So during our study of the grouting, when we here we find out that the percentage of change of unit weight is equal to the Pg by Ksb. Where Pg is here the grouting pressure and Ks is the soil bulk volume. So after putting all the values, let me Pg is here 20 and grouting soil bulk modulus is here 200. So we find out that the change of unit weight is or increase the percentage of increase of unit weight is here is 10%. The correct option is here is option D. Now come to the question 9. So it is said that a Biennial fluid has a yield strength tau s is equal to the 10 Newton per meter square. The soil has permeability K is equal to the 5 into 10 to the minus 5 meter per second. Porosity is equal to Np is equal to 40%. The unit weight of the grout is 10 kN per meter cube. The viscosity of water is 1 centipoise. The unit weight of water is 9.81 kN per meter cube. The effective diameter of the pore in the soil based on the equation have to find out. So we know that the cohesion equation because we given one equation for the BNO fluid, find out the effective fluid. So here it is D is equal to 2 into root over 8 mu k into k divided by gamma w into n. After putting all the values in this formula, we find out the effective pore base is equal to 0.02 mm. So the correct option is here it is option A. Now the last question of our assignment problem and also the last of our discussion said that for the given data of question 8, find out the minimum pressure gradient needed to be overcome the A step. Here pressure gradient is nothing but the minimum hydraulic gradient. So for being a fluid, we know that the hydraulic gradient is equal to minimum hydraulic gradient to overcome the yield strength is equal to the 4 tau s divided by d into gamma g. And tau s is the yield strength, d is the effective pore space, and gamma g is the uh, uh, unit weight of the grout material. So we know in question it is given tau s is given 10 Newton per meter square. D already we find out in previous problem option in question 9, and gamma g is given as 10 kilonewton per meter cube. So after putting all the values, we find out that the minimum hydraulic gradient, or we can say minimum pressure head pressure gradient is equal to 200. So correct option is here is option B. So now we stop here. It is already 8:12. No need to discuss further. During our session, we discuss about during this session we discuss about the grouting material, defect of the grouting, whether it is used, what type of equipment we use, like that. And after that, we try to solve, find out some equations regarding the injection problem, injection of the grouting, and then we try to solve one problem and also try to solve previous experiment question. So after all that, I think there is no further discussion is required during for this grouting, and we now stop here by now. I stop our meeting, and we uh, again we meet again we meet in the next week. So till now, be happy and enjoy your weekend. Now we uh, uh, stop our or leave our meeting, and I stop here. So thank you everyone.